Hello everyone, this is Steve with RF Technology. In this video I will be going over the IP Commander software and how it's used to monitor and program the Eclipse series base stations over a wide range of features and applications. When you start up the software, it brings you to the base station menu, which stores a list of all the repeaters or base stations that the IP Commander can connect to, and this is also where you can add additional base stations into the mix. In this demo, I'll be using my VHF demo. Connecting up brings us to the overview screen. We have the operational channel, currently set to channel 0. The channel name is Demo 2, receive frequency and transmit frequency. In the networking block, it shows the networking name, IP address, subnet mask, gateway. SNMP trap sync, we can send the trap sync information to multiple repeaters or computers for monitoring. In the version, we have the hardware version, the software version that's currently in operation, and the database, and the serial number of the unit. Down here in the real-time section of the screen, we have RSSI, carrier to noise ratio, and in P25 mode, bit error rate. We are currently set to receive any NAC code or a CTCSS of 123.0 in analog. Current operational temperature of the repeater is 41 degrees centigrade. Down here we can set the power level of the exciter. It's adjustable in 0.1 watt increments from 0.1 watts to 5 watts in VHF to 3 watts in UHF and 800 megahertz. Keying up radio in the analog mode shows the receive leg green and the transmit leg orange. This is our indication of analog. It shows our receive signal strength, carrier to noise ratio, and the power output. Switching to the P25 mode, we have the same signal to noise, bit error rate, carrier noise ratio, but we have blue for the receive leg and pink for the transmit leg to indicate that you're in the P25 mode. Currently we have no voting set up on this repeater and no simulcast. Moving on to the top ribbon of the IP Commander software. Clicking on File will bring us to the base station menu where you can select which repeater or base station you want to connect to. Under Calibrate, it's best to use a precision service monitor to calibrate the codec RF power and calibrate the RSSI against a known standard. In the admin bar, we can add or remove users to the IP Commander. Under base station software, it'll store 2 versions of firmware, the present active version and the older version that was in. If you upload another new version of firmware and it were for some reason get corrupted, you can always roll back to the older version and keep it operational. Backup and restore, you can back up your present file or restore from a previous file. Load encryption keys. This feature is currently grayed out because it's not enabled in this base station. We can support AES and DES encryption keys through the IP Commander. Hovering your mouse down by the status bar will show you what features are currently enabled in via the IP Commander in the base station. Load license. We can add additional features to the RFT Eclipse 2 base station by loading in a new license file. Check for updates is currently not implemented, and if you're on a very slow connection, less than 9600 baud, click here and it'll slow down the response time of the IP Commander software. Reboot base station will send a reboot signal to reboot the base station. Moving on to the signal screen, in this software-defined base station, the signal screen uses a very unique drag and drop interface. This gives you the ultimate software defined flexibility. You can build your own radio on screen, or we can do it for you. The various blocks on the right can be positioned and interconnected to set the base station controls, features, and functions. Hovering over the function blocks will give a short description of what they are. We have a POXEG paging encoder and decoder, a priority add block, an add mixer block, tone encoder decoder for CTCSS or digital coded squelch, a voice report generator, pre-emphasis and de-emphasis, an expression block, a phase invert, a gain block that can also be used to reduce gain, CWID, tone generator, an audio notch filter, a PTT delay, high pass and low pass filter, protocol filter, band pass and band stop filter, general purpose data input, network blocks, 4-wire E&M line in and line out blocks, a data in and out, microphone, and a multi-CTCSS and encoder and decoder. Some of the function blocks that are not shown because they are not licensed to this base station are the onboard vocoder, AES and DES encode and decode crypto blocks. In this example showing right now, we have a very basic analog and P25 receiver connected to the analog P25 transmitter. The voice report is connected directly to the onboard speaker. If we wanted to have this output of the voice report also go over the air to the portables, we can do that by putting in an add block. And hit apply. This will now send any of the alarms, whether it's high power, high SWR, high temperature, that would go to the local speaker, will also go over the air to the mobiles and portables. Configuring for a line in, line out on the 4-wire E&M. It's as simple as dragging, dropping, and connecting the lines up. Then again, the line input can only have one input over on the transmitter, so we need another add block. Now we got the analog P25 repeater connected to our 4-wire E&M. Next example, we'll use the DFSI console network block. Hit apply, and just like that, we've got our analog P25 repeater going out to a DFSI compliant console. Now, there may be instances where you want to separate the transmitter receiver into two different legs, or the digital and analog into two different legs. That can be accomplished quite easily also. We use the protocol filters. You drag them in, they default to the analog mode. Right clicking, select edit, change it to P25. For the digital side, we'll drag in the analog side, which is fine as it comes in. From the analog side, we need to go into a tone decoder for CTCSS. Go to an add block. And out to the network. Basically the same thing on the transmitter side. Change that to a P25 mode. Analog mode. We'll go to a CTCSS tone encoder. Bring in our add block. and out to the transmitter. Hitting apply will send the new design to the Eclipse 2 base station. I'm going to cancel this. You can save any of your configurations that you come up with as a name that you call it. Just change the part to the left of the @ symbol. You can reload a new base station by hitting open. The plus and minus on the magnifying glass, you can shrink it down so it all fits in the screen. And that basically is how you design your own radio. If you have more questions, please contact us at RFTA, and we will be glad to help you design your own radio. Thank you. Moving on to the Channels tab, we have the repeater is capable of 256 channels. Currently have 2 channels, channel 0 and channel 1. Clicking in the name field, you can change the name of the base station. Clicking in the receive frequency, you can change the receive frequency, and the transmit frequency will be done the same way also. In the overview screen, it shows what we're currently set for: analog and digital, 12.5K, CTCSS of 123.0. The FM/P25 tab, we can have 25 or 12.5K bandwidth, analog only, P25 only, or mixed mode if you have the P25 license along with the analog. The subaudible field will only show up if in the signal map there is a tone decoder, encoder in the field. You can select your CTCSS tone. You can also select your digital coded squelch. Mute RSSI. This uses a combination of the RSSI value and the carrier to noise ratio, and it needs both of them before we'll unmute the receiver. You can disable one or the other of the fields by disabling the carrier to noise ratio, changing this value to 0, and it will rely only on RSSI, or setting the RSSI value to a level far lower than the noise field of the floor of the repeater, and it will rely only on the carrier to noise ratio. The C4FM tab is used for testing and should be left at no pattern. In the P25 mode, clicking the Any NAC button will make the repeater unsquelch or open with any NAC code. Unticking it, you can enter the NAC code you desire, such as 7F. F7F will cause the transmitter to set its NAC code based on the received NAC code, or you can any other NAC code that you desire in there. On the transmit side, you get your overview screen. In the FM and P25 tab, you have your deviation, hang time of the repeater, transmit time limit of 3 minutes, and you have your protocol, FM, which is analog, and P25. Subaudible tone, again, will only show up if it's in the signal map screen. CTCSS tone of 123.0, and we have anywhere from none to multiple different types of reverse bursts. Maximum deviation and a no tone period. You can also select digital coded squelch here. CWID will also only show up if it's in the signal screen. This is the field where you'd put in your FCC call sign. You can use whatever frequency you want. I like 1000 hertz. Morse code speed of 20 words per minute, and 18,000 seconds, which is 30 minutes between IDs. P25, same as the receiver, the NAC code, any NAC ticked, it'll transmit any NAC code that comes in. And that's how you program the Eclipse 2 base station. Thank you.